Arkadaşlar, how do I find the coefficients of a cosine function is the next question that I will pose to you. Here is my cosine function. It starts from 1, it goes down to -1, and it goes up to 1 again. And this is my period, you see? And I will only focus on this part. This is my period. And what is my period? It is 0.5 seconds, okay? The first thing that you need to do in such questions is that you should find the period first, because you're going to use them in your formulations like that, okay? 1 over t from 0 to t, f of t, and so on. So this is all about finding the t for the first time. Then I'm going to put cosine 4 pi t here, okay? And if it is like cosine 4 pi t, omega 0 is equal to 2 pi over t, and this is omega 0. And I will say, okay, 2 pi, 4 pi is my omega 0. So t is going to be equal to 1 over 2, right? So this will change, and t is going to be equal to 0.5 or 1 over 2 seconds. So you can immediately determine your coefficients like that. And then you're going to see that this is like 1 over 0.5 I put here. And my period is 0.5. The boundaries of my integration is going from 0 to 0.5. And then I'm going to put cosine 4 pi t, and then e to the power j 2 pi n t over 0.5, okay? I put everything in the formulation. This is where I start my discussions. It's very critical for you to write this. In any questions, in any exams, I will give you these formulations, but it's critical for you to understand where I should use it, where I should use each formulation. And then I'm going to use this trick right now. Again, Euler's relation. You are going to use Euler's relation very often. If you put cosine t, like this is e to the power jt plus e to the power minus jt over 2 is cosine, and sine t is equal to e to the power jt minus e to the power minus jt over 2j. Okay, don't forget these things, and it's very critical for you. I'm going to write this one here, e to the power j 4 pi t plus e to the power minus j 4 pi t divided by 2 times e to the power minus j 2 pi and t divided by 0.5 dt. From 0 to 0.5, 1 over 0.5 is 2, okay? So again, this will be 2 pi over 0.5. It's going to be like 4 pi and t. So I have this situation, 0 from 0.0.5, and this 2 will be cancelled by this, so I will get rid of that. So I will have j 4 pi t times e to the power minus j 4 pi n t plus e to the power minus j 4 pi t times e to the power minus j 4 pi n t dt, okay? So it is like something like that. So what will I see here at this point? It is, let's divide it by like that. It's going to be from 0 to 0.5 e to the power j 4 pi 1 minus n t dt plus 0.0 from 0 to 0.5. I'm going to write this one e to the power minus j 4 pi 1 minus n 1 plus n t dt. Okay, so this is like minus, this part is the common part, and then this is like 1 plus n. Okay, so what are the coefficients then? Except from this, I'm gonna get this one down, 1 over j 4 pi 1 minus n e to the power j 4 pi 1 minus n t from 0 to 0 0.5 plus 1 over minus j 4 pi 1 plus n e to the power minus j 4 pi 1 plus n t from 0 to 0 0.5. Okay, so this is all about putting 0 and 0 0.5 in place. So it becomes like 1 over j 4 pi 1 minus n e to the power j 4 pi 1 minus n times 0 0.5, okay, minus e to the power 0 is equal to 1, right? Plus 1 over minus j 4 pi 1 plus n e to the power minus j 4 pi 1 plus n times 0 0.5 minus 1. So as you can see, I can always find out solutions like that, and I can find C1 being equal to, if you put C1 as this one, right? Because if I put 1 here, it will be 1 over 0, so it will be infinity. So this, I cannot use it here, but here I can say 1 over, it will be like from 0 to for n for n arkadaşlar, for example, if you put 1 here, what will it be? 1 minus 1. So we are not going to be dealing with 1 right now, okay? For n not equal to 1, I'm going to do this later. And for n not equal to 1, if I come here and look at this part, arkadaşlar, first, okay? So e to the power minus j to 4 pi times 0 0.5, it's 2 pi, 1 plus n minus 1, okay? This part is this. So what is this? This is always 2 pi, and it's multiples, right? 2 pi, what was e to the power j minus j 2 pi? It is always here, and it is always 1. This part is always 1, okay? So you see 2 pi, 4 pi, 6 pi, it's always coming here, and the angle is 0 or 2 pi. I mean, it's like cosine, and cosine 0 is always 1. So this part is always going to 0, okay? So this part goes away. I'm only interested in this part right now, and I'm not dealing with 1 for the moment. And it becomes like e to the power 1 minus n, okay, and then e to the power j 2 pi 1 minus n minus 1. I'm just focusing on this part. What is this? Again, if n is different than 1, this is again always 1, and 1 minus 1 is always 0. Okay, so all the coefficients other than 1 will be 0 arkadaşlar. Okay, Cn's are equal to 0 other than C1. Okay, then I'm going to come and find out C1. How do I find C1? I'm going to put 1 here. Okay, then it will be e to the power j. Sorry, let me come to this point. It will be like integral e to the power j minus j 2 pi 4 pi t dt, right? So, sorry, let me write it that way. And I should go to the next. Phase. What did I tell you? E to the power from 0 to 0.5, e to the power j 4 pi t 1 minus n dt. Okay, this was my original stuff. It comes like that: e to the power j 4 pi t 1 over n 1 minus n divided by I 4 pi n I 4 pi 1 minus n, and it is going from 0 to 0.5. Okay, so for n equals 1, for C1, okay, I'm gonna be directly dealing with this one. Okay, 0 from 0 to 0.5. We said that for all n's other than 1 and minus 1, n equals 1 and n equals minus 1, they were all equal to 0. But for this one, I'm going to put e to the power j 4 pi t 1 minus 1. Okay, what is this? This part is 0, so it is 0.5 1 times dt. This is 0, 1 minus 1, it's 0. E to the power 0 is 1, so this becomes t from 0 to 0.5, which is 0.5. Okay, so C1 is equal to 0.5. If we say minus 1, so this will be 2, C minus 1 from 0 to 0.5, e to the power j 4 pi t times 2 dt. It will be 1 over j 8 pi e to the power j 4 pi 2t from 0 to 0.5, and it will be like, again, this will be 1, and this will be e to the power j 4 pi. E to the power j 4 pi is always 1, and 1 minus 1, so it will be 1 minus 1 is always be equal to 0. Okay, so C minus 1 is also equal to 0. So, but we don't do this way, arkadaşlar, for C minus 1, because our signal is a real signal. C1 and C minus 1s are equal, and it's 0.5. Okay, so critical thing is that if you have a signal x of t, like cosine 4 pi t, and for the fundamental frequency, if you write it like e to the power j 4 pi t plus e to the power minus j 4 pi t divided by 2, then this divided by 2 thing is already like 1 over 2 here, 1 over 2 here, okay? So this is C1 and this is C minus 1, okay? So for cosine and sine signals, we always write the Euler's relation like that, and the coefficients are written accordingly. Okay, this is very important. Let me write once more. So how we deal with C1 and C minus 1? We write Cn, the original formulation. This was like synthesis equation, okay? And it's like C1 times e to the power this plus C minus 1 e to the power this. And this is like t is 0.5, then it becomes 4 pi. And because this is 0.5 and this is 0.5, and we take the parentheses like that, it becomes this over 0.5 becomes over 2, and this is already like cosine 4 pi t, right? We take this part and write it as cosine 4 pi t. So if we say, if we have cosine 4 pi t, our f of t is like that, and the coefficients are 0.5 and 0.5. For example, if I have a sine 2 pi t as my signal, then I would write it like e to the power j 2 pi t minus e to the power minus j 2 pi t divided by 2j, and this is going to be my sine signal 2 pi t. And what is C1? It is 1 over 2j, okay? The coefficient here is this. C minus 1 is equal to minus 1 over 2j, okay? In cosine and sine functions, we just write the Euler's relation and then obtain our coefficients accordingly, okay? See you in the next video.